Welcome again to Let's Talk Advanced Chemistry, Chemistry 2 with Pastor Dan. We're going to look at something called the Nernst Equation today. The Nernst Equation is defined as, or expressed as, it's originally identified the equation delta G is equal to delta G prime plus RT natural log of Q. Remember when we talked about Q before is if the reaction has equilibrium or not. So we're going to put the values from an equilibrium reaction. We talked about that before in Chem 1. So we're going to find the value of it. And the way that we do that is rearrange it to look like this. E, standard energy, the standard EMF. Start this again. Stop, go back, replay. The EMF at any condition is equal to E prime, the standard, minus 2.303 RT over NF times the log of that value Q, where R is 8.314 joules per mole Kelvin. F is the Faraday constant, 96,500 joules per mole volt. And N, of course, is the number of electrons. Now, Q is the concentration of all reactants and products. We consider that as if it's at equilibrium, even though the reactions are direct. And then we also have a value called E is equal to E prime minus 0.0592 V volts over N times the log of Q. And we do this when we're at standard conditions. What are standard conditions? When the temperature is 298 Kelvin or 25 degrees Celsius. All right, so we're going to look at these two equations, this one for any set of conditions and this one at standard to work through. So let's try one of them here. Okay, first one, the reaction of bromine plus lithium gives us lithium plus 2 bromine, and that's the reaction balance. What we're going to do here is...
No, it's not balanced. We'll balance it later. I'm sorry.
Is the reduction, the standard reduction potentials we had before, and that chart's right over here as well. All right. So we split our reactions and then find our values inside of there. So that means for our standard, cathode minus the anode, this has to be my cathode.
Let me pause this a second and I'll get this set up correctly here. Bear with me as we have some minor technical difficulties. Alrighty. There we go. Put that down there. And then put this back over here. There we go. Okay, those are the two parts. Okay.
That's me, my anode. Put our values in. And we get a E standard, the EMF standard of 4.13 volts. Now, we're looking at 28.5 degrees Celsius, which is not standard, so we're going to have to use this equation right here. Our value of 4.13 volts is my E prime. Now, put the rest of it in. 2.303 times 8.314 times 28.5 plus 273 is 31.5. And then on the bottom, we have 2 because we're losing 1, but gaining 2, so we have to multiply this one by 2. That's why we have a 2. We're going to have a 2 over there. All right. So when we do the log of Q, then how are we going to do this? Well, we're going to have to put a 2 in front of these. And if you look, remember, we said when we do concentrations, we don't pay attention to solids or liquids. Bromine's a liquid. Lithium is a solid, so none of those are going to be there. We're only going to deal with the product side. So it's going to be lithium squared and bromine ion squared, and again, nothing on the bottom. From the problem, we see the concentration of lithium ion is, bromine ion is 0.3355 molar, so that's going to go in there. Lithium ion is 0.5555 molar, that's going to go in there, like that. So we're going to take this side only, take 2.303 times 8.314 times 301.5 equal, divide by 2, equal, divide by 96,500 equal, and then take that multiplied by the log of 0.5555 squared times 0.3355 squared equal, and we'll get 0.044 volts. Add those together, last whole column, 10th place, we're going to get 4.17 volts. So that's
actually, that would be the 100th place. Sorry about that.
The electromotive the EMF, the voltage, is going to be for that cell at that condition. All right, let's try another one. This time we're going to do it at standard conditions for cadmium and silver ion. All right, so split of reactions again. Okay, so we have 0.799 volts and negative 0.403 volts. So this is my cathode, I am gaining. This is my anode, I'm losing. So we subtract those through, get 1.202 volts. All right, now for standard conditions, we're using this equation. E prime is equal to minus 0.0592 volts over N times log of Q. Okay, so we're going to put our values in. And then for our equation here, we're going to have cadmium and silver ion. Again, we don't do silver because it's a solid. Don't do cadmium because it's a solid. Let's put our values in. So take 0.0592 divided by 2 equal times the log of 0.3545 divided by 0.7899 squared. And we get an answer of 0.007268. The last row column is going to...
Again, the reason why we do this, 0.0592 is a constant and 2 is a constant. So we go for here, there's 4 sig figs. That's why there's 4 sig figs there.
Be tenths, hundredth, thousandth place. So 3 decimals right to there. So we're going to get 1.209 volts. All right. Hopefully that's not too bad. Hopefully these make sense. Any questions, remember, ltswpd@gmail.com. Like, subscribe, share, let people know about them if it helps. All right, so here, last one. I'm just going to do this one for you. I'll just give you the answer again. I want you to work through this. We're going to do this at 46.8, so this is going to be the first type, not the second type. We have the concentrations, and just to make sure you got this correct, there are my 2 half reactions. All right, so pause the video, work through this. Ready? Here we go. Answer is 1.106 volts. All right, hopefully not too bad. Take care. God bless.